Good day, class. So let's discuss under polynomial curves gihapon no. Let's discuss the last part for under this topic. So discuss today the concavity and points of inflection in the second derivative test. So ngayon naman ko last lecture nga the way we discuss or the way we consume this topic is that mag-partner ni sila no introduction mo ni and then we progress into kani combine gyapon sa duha increasing decreasing functions and then the first derivative test and then mag-progress pa gyud ta into the second derivative test and you will see later na the second derivative test is actually kumbaga the culmination of what we have learned under the polynomial curves no. So mura siya og all-in-one na ba? You can get the extrema, you can get how unsa itsura sa graph. Pwede sa under ani kay syempre pwede gyapon ka mag first derivative test for to test asa dapat ang increasing decreasing sa function and then finally makakita na din ta kung unsa itsura sa graph. Is it concave upward, concave downward for this part of the interval? Okay? So, bale, mo na ni siya ang tanan-tanan na yun, no? Okay, so what is concavity, by the way? So, it's very self-explanatory and kung makita pa niyo sa graph and then sa physics pag yun na-learn niyo, is like concave. Uh, you can pwede niyo siya i-think as a letter C nga pwede siya na super ana kayo siya super concave or pwede po nakaana lang yun siya gamay nga naka-curve lang yun siya gamay so concave na siya so suppose we have a function here and it is differentiable in an open interval I. The graph of f is said to be concave upward on I if f prime daw class is increasing on the interval and concave downward if f prime is decreasing on the interval. So basically, pagtaan ni mo sa graph, ang concave upward is, looks like this, okay? Upward siya. Okay, upward siya, murag naka-face upward ang iyahang curve, okay? And then, kung concave downward, na pa siya, gibali ang concave upward. Now, unsa man ang iyahang relevance ani when we're talking about derivative. So, when we have a graph that is concave upward, ang f prime doon na class is increasing. That means, another way to look at it is that the graph of f, kaning graph kaning black part dira, lies above its tangent line. So makita niyo mga tangent ay nada sa ilalom. Okay? That's when you can say that your graph is concave upward. Concave downward, ang imuhang f prime is decreasing. Decreasing because ang imuhang, by the way, ang imuhang f prime ang god is katong slope, di ba? So makita nato nga ang yang slope is decreasing, negative po siya, di ba? From a bigger number to lower number. Okay, ang iyahang f prime. So ang graph po ani class lies below its tangent line. So nakita ninyo ang tangent line naa siya sa ibabaw sa graph. Okay, graphically mo ni mo ang tanawon. Pero actually, mas wala mo kita definition class ng concavity. Tagaan lang mo graph. No, para saan ni? Makabulo na ka, concave upward. Okay, concave downward. But as to how we solve and how do we know that it is concave upward, we're going to be learning what we call the second derivative test. Okay, but first, let's have this theorem 3.7 set of tests for concavity. How do we test the concavity? Okay, so let f be a function whose second derivative exists on an open interval I. Okay, so karon di na ta focus sa iyang second derivative. So, mura na siya kuan class. Mura na siya katong decreasing increasing function. Pero this time, second derivative ato ang gikuha. Di ba sa increasing decreasing function, if your f prime, ang sign sa imong first derivative kay positive, then we can say that your graph is increasing, di ba, at that interval. Kung negative po nang imong makuha nga f prime, that means it is decreasing on that interval. It's the same thing here, pero we're just talking about concavity and the second derivative. So when your second derivative the class of x is greater than 0 or basically a positive value for that interval, no, then the graph is concave upward. Ano lang? If your f double prime of x is less than 0, so kana kay positive, kani kay negative, then the graph of f on that interval is concave downward. Okay? So, balik ta, if your f prime of x sa first derivative is positive, then it is increasing, di ba? Ano man to tong sign na if your first derivative of x is less than 0 or a negative value, then decrease ang iyong function. Here in concavity class, if your f double prime of x is greater than 0 or positive value, then it is concave upwards. So ano na pala itong sign? And then your f double prime of x is a negative number, then it is concave downward. Ano lang? Na ay parallelism sa duha class, no? Pero ang isa is increasing, decreasing, isa is concavity. Okay, so suppose we have this function. So we are to determine the open intervals on which the graph of f of x equal to 6 over x squared plus 3 is concave upward or downward. Now, tagaan mo problem mga inani class. Then on din ninyo, unsa gipangita? Concavity. Concavity. So second derivative ang kaon. Okay? Pero kung papangitaon mo og behavior sa graph, kung increasing or decreasing, dira na din mo magamit. First test sa first derivative test. Okay, usually kaya ma-interchange mo sa mga estudyante. Pero, again, increasing, decreasing, first derivative. Concavity, concave upward or downward, second derivative. Okay, so, saan na ito pagkuha? Okay, so, tanaw na ito class ang dili tama sa second derivative. Now, ang kanindot ani class, kung kabalo na mag first derivative test, sa'yo na kaya mo second derivative test. Ang madugang lang sa step is that we just need to get the second derivative of the function and that's it. Okay? So, natay f of x, di ba? So, ato lang yung gibalhin din sa taas para negative 1 yung exponent and then we get the first derivative no, by differentiating. So, when we differentiate, mo ni ang iyahang expression. Now, concavity man itong ikuha, i-differentiate pag na ito class. Okay? Ang first derivative para magkuha tag second derivative. So, we use the quotient rule and then we get this expression. Di na ako isa-isa. Kabalo naman sa quotient rule. Okay? So, this is now our second derivative of our function. Now, unsa na ito pagkuha karon sa intervals? Di ba sa first derivative test, when we get the expression for the first derivative, atom din siya equate to 0 or kano siya ma-undefined to get the critical numbers. Here class, same process, okay? Kaning second derivative ng expression ato na siya i-equate into 0 or kung kano siya ma-undefined, na 0 and then undefined. And then we get the numbers or we get the values of x. Now that values of x are actually later na ko-introduce mo sa tawag ang mga points sa graph, no? So, first, equate na to ang second derivative na to 0. Unsa na mga values sa x na makapa-0 sa to second derivative. So, second derivative, no, we have a rational function. So, numerator must be 0 para ma-0 siya. So, ato lang equate ang x squared minus 1 to 0. So, then we have x plus minus 1 atong x. Okay? Para ma-0. And then, kano sa siya ma-undefined. So, ma-undefined siya class if your denominator is 0, correct? So, if you equate natin ng 0 class, we get a negative x squared is equal to negative 3. So, that means your x is imaginary here. Dili siya pwede, dili natin siya makonsider, dili siya part sa atong domain. Kaya di ba x squared class is always a positive number? Okay, positive number siya. Dili ni man negative ever unless if it is imaginary. Okay? So that means, wala tayo value sa x nga makapa-undefined. Actually, kung tanaw lang mo ang denominator, makabalo na ka-class nga, no? Mathematically, of course, mo ni siya ang proof na to nga imaginary atong x. Pero kung tanaw sa itong denominator, kano sa siya ma-0, it's very easy. Kaya ano, kani siya positive. Okay? Positive. Kini siya, it's always gonna be a positive value. So meaning, kung always ni positive, dili ni siya ma-0 ng expression. So never siya ma-0 kung tanaw lang ni mo siya. Okay? So that means, wala tayo value sa x nga makapa-undefined. So ang ato ra karong mga important numbers to consider class are negative 1 and positive 1. So, muna na siya ato ang i-consider nga part sa ato ang interval, no? Endpoint sa to interval. So, first interval is that same lagi apong class. Magnagi tayo number line dira, nara din number line dire. Buhat na ko, okay? So, the first interval would be the negative infinity to negative 1. Open interval na siya, negative 1 to 0. Sorry, negative 1, 0 ko there. Negative 1 to 1, and then 1 to positive infinity. Okay? So there are 3 intervals. Kaya naman tayo duha ka numbers nga nakuha, no? So, pareha rin pa siya process sa first derivative. We are going to define the intervals. Na-define na tulo ka intervals. And then we're going to get some values, no, between the intervals. So for the first interval, we get negative 2. And then get the value then class of the second derivative at x is equal to negative 2. Okay, so diri nato siya i-input sa atong second derivatives. So what will be the value of that? Wala na niya gibutang value basta nakakuha ta og positive value. So positive value, it means that this is concave upwards. So sa kining interval class, negative infinity to negative 1, concave upwards. So ato lang gibutang nga ingana siya itsura. Later na ng graph. And then sa second interval from negative 1 to 1, kanatong 0 nga value. So f double prime of 0 is a negative value. Okay, so atong conclusion na is concave downward. Then finally, we have the third interval. X is equal to 2 itong ikuha nga value. So the sign of f prime of 2 is positive. Okay, greater than 0. So atong conclusion is concave upward. So kung ano to karon sa graph class, ano sa graph, it is indeed, no, sakto gid niya siya nga concave upward. Actually, mo to ni i-graph sa Desmos, mo na pa na siya gamay dire. Murag mo na siya gamay. And dili pa sabot nga dili na siya, di mo siya concave, ma'am. Actually, concave na siya. Basta kaya naka-curve na siya, gamay kayo. Plus, concave na siya. Okay? So, this is concave upward. And then the second interval mo, concave downward, correct? And then the third interval is concave upward. So, sakto na siya. Okay? So, another example, within your balikan later, we have another example here. So determine the open intervals on which the graph of f prime, f of x equal to x squared plus 1 over x squared minus 4 is concave upward or downward. Okay, so again, we differentiate now until the second derivative. So differentiating this rational function, we get this expression. And then again, differentiating to get the second derivative, mo nito makuha. Okay, so karon same process. Ato na gyapon equate to 0 or undefined. So para ma-0 siya, dapat imong numerator kay 0. No, pareha ra gyapon kaso x squared gyapon, even exponent. This will always be positive value. Yeah, plus you go 4 dira. So this will never be 0. So tanaw na gyapon nato mathematically. We get x squared is equal to negative 4 over 3. So again, wala tayo value, real number class nga makapa-negative ani, unless imaginary. Okay? So again, di na siya part sa itong domain. So wala ni siya labot. Okay? So f double prime of x, kung saan siya ma-undefined, ato na equate sa 0 atong denominator. So we have x squared minus 4 na is equal to 0, and then we get x is equal to plus minus 2. So, natay duha ka numbers. Nag-consider negative 2 and positive 2 mo na siya itong endpoint sa mga intervals. So again, kung duha itong nakuha ang number, then we get 3 intervals for that. So we have here the negative kaning interval, negative infinity to negative 2. And then we have negative 2 to 2, and then 2 to positive infinity. So same like yung class, we get test value sa first interval, negative 3. We get a positive value. Okay, so conclusion na to is concave upward. And then second interval, atong gikuha nga value is 0. So f double prime of 0 is a negative value that is concave downward. Okay, again ha, di rin na siya i-input sa second derivative ng expression. Okay, third interval, we have 3 atong value. So f double prime of 3 is a positive value. So concave upward siya. Okay, so kanina siya class, mga sign, ato rin ko, guide rin na to para ma-visualize na to. But the real graph good is this. Okay, so if we graph nato ni, yan yung itsura. So from negative infinity to negative 2, concave upward. Okay, correct. And then second interval, concave downward, correct. Third interval, concave upward. That is correct. Okay. So, okay, let's go to the definition of points of inflection. Okay, so katotong magikuha ng mga numbers class for when your second derivative becomes 0 or undefined. Mo to siyang gitawag na to nga points of inflection. So kung sa first derivative test, itong itawagan na is a critical number, no? To determine the possible relative extrema and also endpoints sa mga interval na mo na siya ang mga critical numbers, di ba? Sa first derivative. Sa second derivative, ato kung tawagan nga points class or points of inflection. Okay? So, kano siya makatawag of points of inflection? Siya, if nga ni, if you have a function, no? Nga nakay part sa mong function nga concave upward and then ni concave downward. Kung asa na siya gasugod og change class, mo na imong point of inflection. Okay? So, para saan na? Okay? Mo na imong point of inflection. And same is true here, point of inflection. Now, kung saan man na mo siya matawag na, usay man god malibog ka, dili ang point of inflection, ma'am. Kay bas ma-part pa niya siya sa concave upward ba? Di na siya ni concave downward. Okay? Another way to look at it, class, is that if your tangent line, okay? If your tangent line sa imuhang graph, ana nga point crosses your graph. Okay? Nakita niyo ang kuan. The tangent line crosses. Kung diri man gud ang imong point, buta na to, wa ka kabalo ba nga mo na imong point of inflection. So, gaban na ka diri. Ang tangent line ana class will look like this. Okay? Sorry. Kana siya, ang imong tangent line look like this. Wala siya ni cross sa imong graph. Your tangent line sa point of inflection always crosses your graph. Okay? Mura yung kuan ba? So nilapos siya ba? Para saan nilapos siya. Kanipod. Okay? So these are the points of inflection. So naladyo, note that the graph crosses its tangent line at the point of inflection. And concavity of F changes at the point of inflection. Okay, so don't worry, di man magbana-bana dre asa dapat mo cross ang tangent line. Okay, that's so impossible. Makita nito sa ato mga mata. That's why we have the second derivative test to find these points. Okay. Okay. Again, ato na na-solve ganina to locate possible points of inflection. Now, we know siya possible points of inflection. It's because class, same ra siya sa ideas sa imong critical numbers. Yung critical numbers are not necessarily the relative extrema, di ba? These are the points sa imong graph na possible nga relative extrema nimo. Okay? So, these are also used to define the intervals. Dira ma-change ang behavior sa imong graph, no? Pero dili siya necessarily extrema siya. In the same way, sa imong point of inflection, dili siya necessary. I mean, sa may makuha nga mga x sa second derivative nimo, dili siya necessary nga points of inflection yun. It could just be possible points of inflection. Okay? Now, how do we get that? Of course, katotong resolve to ganina, we equate f double prime of x to 0 or when your f double prime of x does not exist or undefined. So, katong nga mga values are possible points of inflection na dayon. Okay? Now, nag-note siya daw, this is similar to the procedure for locating relative extrema of f in the first derivative test. So, sa'yo nagiging siya class, medyo magdugang lang taga may step. Okay? So, let's have another example. Okay, suppose we have this polynomial function, x to the fourth minus 4x cubed. So we determine the points of inflection and discuss the concavity of the graph. So, okay, we get now the first derivative. So, mo ni siya. And then the second derivative, saka na siya. Ito na butang derivative para ko. So we have the first class is that since polynomial maninod, of course, hindi siya ma-zero, hindi man siya rational. I mean, hindi siya ma-undefined, sorry. Hindi siya ma-undefined. So, equate na siya to 0 and then we get the roots or the values of x nga pa 0 siya. So, there are two factors. We have 12x and then we have x minus 2. Okay? So, the value would be x is equal to 0 and the other is x is equal to 2. Okay? So, we have the interval negative infinity padulong sa 0. And then nasa tayo 0 padulong sa 2 and then 2 to positive infinity. Okay. So, same process. We get the test values, random numbers between that interval. So we have -1. Then f double prime of -1 is a positive value. So, conclusion na to, concave upward. From 0 to 2, we have 1. So f double prime of 1 is a negative value. So concave downward. Okay. And then the last interval, we have 2 to positive infinity. X is equal to 3 itong value class. So f double prime of 3 is a positive value, concave upward. Okay. Then finally, muna niya ito ang graph. Okay. So from negative infinity to 0, nara siya class, concave upward. That is correct. And from 0 to 2, concave downward. And then finally, from 2 to positive infinity, concave upward. Okay? So again, these are our points of inflection. So again, kung point na siya, of course, dapat na siya y value. Pwede na to siya. Kung magkuha din kag value class niya nga 0, x is equal to 0, ang atong point of inflection specifically should be, ato na ibutang dili, points of inflection. Of course, kung point na siya, dapat na siya x and y value. Now, if your if your value of x is 0, then what is the value of y? Ato na siyang i-substitute diri sa atong original function. Okay? So we have, pwede na nimo tutukan class, ang imong y value na is 0 gapon. So mo na tong first point. And then the second point is 2. Unsa ka yung y value, ato ni siyang i-calculate sa na class. Wala ko y value. Hindi ko naman na. Hindi ko na ko makita ma-estimate sa graph 16. So, again, kining 2 dire, substitute natin sa original function para makuha na ito iyang y equivalent. Minus 4. Okay, 16 yun din, negative 16. So, we have negative 16. Okay. So, again, kung point, naka x, y coordinate. So, the first point of inflection is 0, 0. And then the second is 2, negative 16. Okay, okay. Gipangutan na mag-uta dire class. Kung kapag pangutan na, diretso na tayo ng conclusion. Pero, gipangitaan mo tag points of inflection and then the concavity. So, ato na siyang specify. Okay? So, moving on. Okay. In addition to class, to testing for concavity, the second derivative can be used to perform a simple test for relative maxima and minima. So, unsa na siya? Okay? So, naiba na natay ko. Di ba na natay intervals for testing the concavity using the second derivative test? Okay? So, katong mo niya ito ang first condition na, atong condition that is your second derivative must be positive number, okay? Concave upward, okay? And then, balik sa today sa ito, balik sa ito sa concave downward, your second derivative must be a negative value on a concave downward siya. Now, unsa niyo ma-notice, for both graphs class, both the concave upward or concave downward, naka-extrema dira. Diba? Kung concave upward siya, of course, naki-value ng pinaka-gamay or the minimum. Okay? So, meaning di if you have a concave downward nga graph o part sa imong function, naka-isa liya ka relative minimum. Okay? Naka-relative minimum. Sa imong pong graph nga concave downward, nasa kay maximum. Okay? Pero how do we test the value? Kung ang imong first derivative class is equal to 0, di ba? Remember sa itong first derivative test, kung 0 ang ato ang slope ana, then mo na ang ato ang relative extrema. Same is true here sa imuhang concave downward. Kung 0 ang imuhang slope ana first derivative, then that is a relative extrema gihapon. Pero ang nakalindot ani is that when you know that your graph is concave upward, nga i-test ni mga value class, imong critical number nga nakuha nimo sa first derivative, pwede na tama ka conclude diretso nga it is a relative minimum. Kaya naka-concave upward mo ka. Okay, I hope naka-gets mo. Kung naka-concave downward po ka, ang imong critical number nga i-test dire, automatic, kung 0 ang imong makuha class, automatic na siya relative maximum. Imposible magud ka nga mag-concave downward niya. Minimum ninyo eh. Diba? So, concave, so maximum ginani mo. Kinaka-downward man siya. Okay, so sige, let's test. Ano. So the second derivative test, actually same naman to kaganino, no? Pero kini siya gidugangan lang niya og relative extrema sa pagkuha. So again, your f double prime is positive, then f has a relative minimum on that point. Kaya again, kung positive siya, concave upward, meaning na kay minimum dira. Kung kani siya less than less than 0, negative number, then f has a relative maximum at that point. Okay? Now, kung ang imong second derivative class is 0. Dili na siya pwede ma-fail ang imuhang test ana. Therefore, ang imuhang imong gamiton test, sorry, imong gamiton is ang first derivative test. Okay? Wala mo gay kontra, dili mo siya contradictory ang imong second o first derivative test. Okay? Di mo na siya diri nga given di ay nga ang imong f prime of c is 0. Okay? And then adding to that is kanina din nga condition. Pero again, if naa kay 0 class nga first derivative at that point, unya ang imong makuha po nga second derivative at that point is 0, ma-fail na siya. Dapat either positive lagi siya or na negative value. Okay? I think nako example na diri nga ma-fail ang test. Okay, let's go to this example. Sige. So, suppose we want to find the relative extrema for this function, no? Using the second derivative test. Okay. So first, hoon na to class ang first derivative. Okay. Expression, gusto na ako daan para data. So the first derivative, ano is, of course, you differentiate this. And then, ato siyang equate to 0 class or kanus siya ma-undefined. Yun naman, dili sa nato siya i-differentiate rate. So, ato siyang kung ano mga critical numbers sa imong first derivative. Okay? So, makakuha ta karon class o duha ka factors kana. Okay, so kanus na siya ma-0. First is kung 0 ni. Okay, so nakay 0 dira. And then kung ma-0 ni, nakay roots nga plus minus 1. Okay. So therefore, you have three critical numbers. Diri lang sa siya class. Wala sa tayo buhato na ni karon. Ato lang siya standby lang sa nga mga numbers. No? These are the critical numbers. So sige, pasabot ani. Ang implication ani class is these are the possible relative extrema. Okay, relative extrema. So, ato ta karon class sa second derivative. Ato siyang i-differentiate na sa, no? So, differentiating this, we get this expression. Ato na pong equate to 0 or undefined. So, not rational man yapon. So, equate na nato to 0. Okay. So, we get two factors yapon, no? Kini siya when x is equal to 0. And then 2x minus 2x squared minus 2 is equal to 0. So, magpatag plus minus square root of 1/2. So, unsa pa na yung mga numbers, dili ni siya critical numbers itong tawag, no? These are the possible points of inflection. Okay. So, karon diri sa tag sa derivative test man tanong kay magkuha man ta og concavity niya. So, kaning mga digit diri mo ni karon na nga to ang endpoints atong graph, no? So, ayaw sa ni-consider negative 1 og 1 kay critical numbers na ito nakuha. Kanila sa ta, the negative 1/2, 0, o positive 1/2. So, we will have 4 intervals. Okay, first interval is we have this interval, negative infinity to negative 1/2. Second interval is 1/2 to 0, kana. Third interval, 0 to 1/2, kani. And then, 1/2 to positive infinity, kana. Okay? Test value, magkuha ito mga test values class. Between this interval natin, negative 1. So, the f double prime test second derivative test man, is a positive value. So, ang kakuha positive, concave upward siya. Okay, second interval, negative 1/4. So, f double prime of negative 1/4 is a negative value, concave downward. Okay, ana. And then, from 0 to 1/2, 1/4 atong kuhaon. So, f double prime of 1/4 is a positive value, concave upward. Lastly, we have 1/2 to positive infinity. 1 atong kuhaon nga value plus f double prime of 1 is a negative value, so concave downward. So, just for visualization, yung ano yung tsura, upward, downward, downward. Okay? For each interval. Okay, now, unsa din natong buhaton? Kabalo na ta sa concavity no for each interval. So, karon for each interval class, this sa atong second derivative test, na atay mga extrema. Okay? First, na atay extrema diri. Okay? Kini nga value, kini nga concavity na atay possible relative minimum, di ba? Kana siya. Yeah, diri sa interval natay maximum. Diri sa natay minimum. And then diri sa natay possible relative maximum. Okay. Karon dito sa first class. Okay? First nga interval. Balik ta karon sa ato ang first derivative, critical numbers nga nakuha. Ato din na siya i-draw sa atong number line class. Now, atong number line, dire no. Okay? Hinahinay na to ni. Mag-add ta karon sa critical numbers. Atong critical numbers class 0, -1 o +1. So, mo nang nag-add ko negative 1, ina na may 0 daan. And then 1. So, kanina yung mga critical numbers, possible ni siya extrema, correct? So, kung possible na siya nga extrema, kana atong kuhaan class o derivative karon. Okay? Magkuha tag derivative ana. So, first derivative atong gamiton kay di ba diri sa kuhaan theorem na to is that your first derivative of that critical number must be 0. And it should be positive para minimum siya. It should be a negative value sa second derivative para maximum siya. Now, kani siya is a concave upward man good, di ba? So meaning, if we get a value here of our first derivative sa kini nga value sa -1, then we can conclude that that is a relative minimum. Okay. So kung kuha na to karon ng f prime of -1 class, ato na siyang i-input dira, no? Of course, 0 na. Magunan na ito na kung ang critical number. Okay? So we have a 0 and f prime of 1 po, 0 gihapon. So, atong conclusion aning duha class is these are relative extrema. Okay? So, balik ta ha. Ang imong second derivative is to test the concavity. The first derivative is to test the extrema. Okay? So, karon kita na to. By the way, nga nung ang 0 kay dili. Kung ano mo gunin mo ang 0 class. Ha? Kung ano to karon ang 0, 0 to siya. Imong f prime of 0 is equal to 0. So makaim ka nga, it could be a possible nga extrema. Pero this value sa 0 class is also a point of inflection. So karon nangutan na ka, is it a point of inflection or a relative extrema? Kung tanaw na to karon class, awa ha, nakakay kuan, concave downward dira ni interval. Nasa kay concave upward. Karon ang imong 0 na adiri. Kung ga-connect na sa duha class, it's impossible that it is a relative extrema. Kay di ba atong relative extrema must be this one and this one. Okay? So karon kung taan na to sa graph di ay muna siya akong giingon di, sorry, muna akong giingon ganina nga. Your f double prime of 0 is equal to 0. Okay, kung i-test na to. And kano sa man na siya sa conclusion na to ana, the test fails at that point. Dili pwede 0 ang imuhang f double prime of that critical number. Kay tanaw na ito sa graph. Nara day ang graph class oh. Iyang from 0 to 1/2 sakto concave upward kana siya. Tama no. Yeah, from 1/2 -1/2 to 0 concave downward. Okay? Considered na siya as concave downward. And then from 0 to 1/2 dire siya gikan. Uy, nag-concave upward siya. Okay? And then 1/2 to positive infinity, nag-concave downward siya. So, unsa din yung 0 dire? Ang 0 di ay, yes, it is a point of inflection, but it is neither a minimum nor a relative maximum. Okay? Your f double prime of 0 is also equal to 0. Okay? So, I think kung maka-remember mo sa first derivative test, ito example nga, kaya lang siya class, no? I think that is x cubed. Di ba di natin ma-consider nga, pag solve na to kay di siya relative maximum, di siya relative minimum. Pero nag-change ang behavior sa mong graph. Yan na siya. Okay? And then 0 po din yung derivative dire. Pero dili siya maximum or minimum. Okay, balik ta karon sa imuhang point nga -1 and 1. So karon ko na to iyang value sa y, ano ra na ko na to -2. So -1, -2 mo yung relative minimum kay naka-concave upward mo ka. Tapos relative maximum po ni mo dire, naka-concave downward. 1, 2. Okay, so that's how you find the relative extrema for your function using the second derivative test. No, moagi gihapon ka og first derivative katong critical number. Okay, ang nakanindot ani class kay di mo ko mangita og kano sa siya increase, kano sa siya decrease, di ba? Para di ba? Kung increasing siya, decreasing, syempre naka-relative maximum dira or decreasing, increasing, naka-relative minimum. Pero ang nakanundot ani is kuan siya, mag-test ang test concavity niya. And then, i-test na ito itong specific point sa critical number within that interval. Ayan na din makakonclude. Okay? Sige, let's have the comparison between the second and the first derivative. No? So, from first derivative, again, ang focus on class is finding the behavior of your function at a certain interval kung increasing ba siya or decreasing. For the second derivative test, different intervals gihapon. However, atong test iyang concavity, whether concave upward or downward. Okay? So, kung saan ito pagkuha? You get the values of x at f prime of x is equal to 0 undefined. Okay? And then, mo ni siyang endpoints ito interval. Sakto? And then, katupod ng mga x plus nga mo-solve na to, gitawag na to siya critical points. And these are the possible relative extrema. Second derivative test is same yapon values of x, pero focus na kalon sa second derivative sa x. Same lagi po process no, we equate it to 0 or undefined. Same lagi po, mo na itong endpoint sa interval yapon makuha itong mga x. Okay? And then, instead of being the possible relative extrema, these x's are the possible points of inflection. And both test class can be used to find the relative extreme. Okay? So, I guess I'll leave this to you, class. I have answers on this, but yeah, para mag-exercise lang mo. These are two functions. I think na po kayo more functions. Yeah. Okay. First is, find the points of inflection and discuss the concavity. So this might come out in the exam. So I suggest you practice this. So you have two functions, polynomial and rational, no points of inflection and then concavity. Same process yapon ka. So atas na ko graph daan in case gusto mo mag-double check sa inyong answer. Okay? Napo-graph diri and then kini the last two functions ang gihatag is para mas ma-practice mo class using the second derivative test, find the relative extrema. So agi gyapon mo ani class, agi gyapon mo get the points of inflection, the concavity, pero mag-add lang mo karon og critical number from the first derivative to solve for your relative extreme. Nagyapon kay graph ng gi-attach sa class para mag-guided mo kung sa itsura sa graph, asa ang mga points na possible critical numbers or extrema and then points of inflection. Okay? So that's it for this lecture, polynomial curves. I'll move on to optimization and related rates, and these are the applications of derivative gamiton ninyo for your PID. Okay, so that would be the end of lecture 13 about polynomial groups. Thank you for listening.